All right, Brandon Clayton here, the Algebra Guy. As you see on your screen, our discussion is how to find perimeter and area. And we're going to look at perimeter and area for a few different shapes. By the end of this video, you'll be able to understand linear, square, and cubic measure. What's the difference between all those? And use the properties of rectangles, triangles, and trapezoids to find perimeter and area and better understand those different properties for each shape. So let's start with linear measure. When you measure your height or the length of a garden hose or a ruler, use a ruler or a tape measure. Just something really straight and you just measure straight across. A tape measure may remind you of a line. You use it to measure things that's linear. The units that we use when we're measuring something that's linear is inches, feet, yards, miles, centimeters, meters, kilometers, anything that's talking about distance, that's linear for the most part. Area, on the other hand, is if you're going to cover a floor. So if I want to cover some area, I'm now looking at not just one dimension, length. I'm looking at two dimensions, length and width. So if I want to cover this floor, I'll name it in squares. Actually, let me read this, make sure I don't miss anything. Area is measured in square units, like these right here. We'll say how many squares do you have? Not just how many centimeters there are, but how many square centimeters are there. We often use squares, inches, square feet, square centimeters, square miles to measure area. A square centimeter is a square that is 1 centimeter on each side. Now, it'd be the same thing if it was a square inch, right? It'd be a square inch on each side, or a square mile. So usually when you're talking about area like land, you'll hear talk about square miles, or some other units that's pretty large. What is the area of this rug here? Let's call this a rug. What would be the area here if each of these squares is 1 foot? So let's say this is 1 foot. And this is a square, so it's the same on each side, 1 foot by 1 foot. What's the area? Well, to get the area, I just simply add up how many 1 foot by 1 foot squares there are, and I can easily see there's 1, 2, 3, 4, 5, 6. So my area here will be written 6 feet in this little square symbol. You can call it 6 feet squared or 6 square feet. That's how you're going to define area. And last but not least, volume. When you measure how much space is filled up in a container, like you're talking about gasoline inside of your tank, or medicine in a syringe, or milk in a container, all those are volume. Volume is measured in cubic units. You're asking now, instead of asking about how long, like how many inches something is, or how many square inches something is, now you're thinking about how many cubes. So I'm going to draw a little three-dimensional, little bitty cube. How many cubes can fit inside of that container? So those are the three units that we'll talk about today. We're measuring the volume of a rectangle or solid. You measure how many cubes fill it up. This is an example. This is 1 cubic centimeter. So all these are 1 centimeters. 1 by 1 by 1, it gives us 1 cubic centimeter. So what would be the volume of this if I said one of these is 1 centimeter by 1 centimeter? If it's a 1 by 1 by 1, what would be the volume? Well, how many cubes are there? So I know there's 9 on top and there's 3 layers. So that would be 9 times 3, which is 27. 27. But I'm going to make sure I put the right units because I'm measuring in centimeters. So I say 27 centimeters cubed. And that's where you get the definition from length times width times height, because we're looking for how many cubes are going this way, how many cubes are up and down, and how many cubes are here. And we measure all those. All right, little quiz here. Can you identify which of these goes into either linear, square, or cubic? All right, so the first one is if we need carpet, is that linear, squares, or cubic? Well, carpet is going to be square. What about an extension cord? Well, that's just a line, so that's going to be linear. What about sand inside of a sandbox? Well, that's how much volume something's going to take up now. It's not just flat. Length of a curtain rod, that's linear. amount of flour in a container, so we know that's going to be cubes because we're filling up something, and the size of the roof of a doghouse. So we're just talking about a roof is going to be pretty flat, two-dimensional. So we're looking at squares. Perimeter is a measure of the distance around something, and area is the measure of the surface that it takes up. So the perimeter here equals, it doesn't equal 4. 1, 2, 3, 4. That's 5. Oh, I'm sorry. I'm counting the wrong thing. That's not a good start. So perimeter is going to be, they're saying this whole thing is 1. So, and that's a mistake that the students will make too. They start counting the squares, but they told you this whole piece is 1. That's 2, that's 3, that's 4. So that's how it's 4. In the area, each one of these, this whole thing is 1. So it's 1 times 1. See, I still want to count these little pieces, but it's 1 times 1 is equal to 1 square inch. Also reading 1 square inch. All right, what's the perimeter of this figure? So we're going to assume that each square tile is 1 inch this time. We're not going to do that same thing where they said this whole thing is 1. We're considering each one of these is 1. And this is 1. So how many, what's the perimeter? Well, perimeter is the distance around something. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 here. 1, 2, 3, 4, 5. 5 here. So that means this is 10 because they're the same, and this is 10. I want perimeter, so I'm going to add up all of that. 10 is 20 plus 10 more is 30. 30 what? Did they give us a unit? Yep, inches. So this should be 30 inches. What about 30 inches squared? No, we're not talking about area. We're talking about perimeter. Speaking of area, what is the area? Well, this is, count up all these squares, or just simply go 5 times 10. So that's perimeter. 5 times 10 will give us an area of 50. So this will be 50 inches squared. And we'll put area here, perimeter there. All right, well, we know how to label a rectangle. We got the length, and the length are the same on each side, the width and the width. We know that all 4 sides are 90 degrees. The lengths of opposite sides are equal, and the width and width is equal, length and length is equal. To find perimeter, we double our lengths because we got 2 of them, add double the widths, and we find a perimeter. Area of a rectangle is just going to be length times width, which we just modeled before. All right, let's practice a little bit. The length of a rectangle, notice I drew a rectangle to help us with this problem, is 32. The width is 20. What's the perimeter? What's the area? So we read the problem. We identify what we're looking for. We're going to just call perimeter P and area A. So what's the perimeter? Well, I know perimeter is equal to 2L plus 2W. And my lengths are 32 plus 2 of the widths. And when I solve that, so what did I just do? I defined it by P and A. I translated into an equation, and now I'm solving it. So I did all those pretty quickly there. Doubling 32 is 64. Doubling 20 is 40. Adding those up will give me 84. 84 what? Let's remember, we're talking about perimeter in meters. So 84 meters. Meters. All right, so what about this area? Well, area is going to be length times width. So area is equal to length times width, and I know my length, and I know my width. So that should be 640, what's the units? Meters squared. All right, then that's it. All right, find the length. Find the length of a rectangle with perimeter 50. So this, I'm going to go ahead and write this out. Perimeter 2L equals 2 plus 2W. And we want a perimeter, so P is going to be 50, 50 inches, and width 10 inches. 50 2L plus 2, the width is 10. So we need the, what are we looking for? Length. Got that? Know what we're looking for. labeled our things we're looking for, and we set it up. Let's go ahead and solve this. So we got 50 equals 2L. 2 times 10 is 20. 20. Subtract 20 on both sides, I get 30 equals 2L. Divide by 2, and that leaves me with L equals 15. So my long side is 15. This side must be 15. And my width 10 and 10. Does that add up to 50? 15, 15 is 30, 40, 50. Yep. So I just checked it. Looks like we're doing well. They wanted, if I wanted to write the right units, I want to put inches on those for the answer, because they said find a length where we got 15 inches. All right, the width of a rectangle is 2 inches less than the length. The perimeter is 52 inches. So here's the problem. It takes a little bit more thinking or work. First, we already read it. We identified what we're looking for. We want the length and the width. Let's identify the names of each one of these. So the width of a rectangle is 2 inches less than the length. So let's just let length be equal to L. And we know that the width must be, the width is 2 inches less than the length. So here's the length minus 2. That's going to be our width. So we got L, L, and L minus 2, L minus 2. Now let's see if we can set up an equation. We know that the perimeter is 52, so we know that when we put it all together, we got two L's here, L and L, that's 2L plus 2 times L minus 2 is going to equal to 52, because we got 2 of those L minus 2. So that's 2L plus 2L minus 4 equals 52. So 2 plus 2L is 4L minus 4 equals 52. Add 4. 4L equals 56. But we're not done. I need to find L. Divide by 4 on both sides. And what is that going to give me? 14. L equals 56 divided by 4. 14. 14 what? 14 for my length. And what's the measurements? Inches. So this is 14 inches. And this must be 2 inches less. So now I know this is 12 inches. Now I want to just mentally check this to see if I'm working it right, because it should add up to 52. So what's 14, 14, 12, and 12? I'm going to double check it using my calculator. Make sure I put these in right. So 14 plus 14 plus 12 plus 12. Yay, 52. So it looks good. We checked it, and we can move on to our next problem. That's similar to the one we just did. Let's do this one. The area of a rectangle's room is 168. So area of a rectangle is 2L plus 2W. And we already know that the area is 168. The length is 14. So we know that the L right here is 14. So we're looking for the width. We did that, and we defined our variables. So we set it up. Now we just need to find what width is. 2 times 14 is 28 plus 2W. Subtracting 28 on both sides will lend us a 140 equals 2W. Divide by 2, divide by 2, W equals 70. So just kind of check this a little bit. Make sure we're on the right track. No, we're not. Unbelievable. I did the completely wrong formula. I did perimeter formula for area. So I apologize for that because you're probably just watching it and like, what is he doing? Or at least I hope you were. So length times width is what I should have done. And how did I catch that, by the way? I was doing my checking and I realized, hold on, this doesn't make sense. And please make sure you do that because, again, like I always say, I probably mess up every video at least a little bit. But it's always something that I can miss. All right, so area is 168. And we got length is 14. And we're looking for W. All right, so a lot more straightforward here. We're going to divide by 14 on both sides to get this one. That becomes 168 divided by 14. And it gives me 12. So divide 14 on both sides. That equals 12. So W equals 12. Did we answer our question? So let's go back and make sure. What is the width? Yes, they just want the width. We got that. All right, we're good. We did one like that. Let's move on to triangles. So what is a triangle? If you think about it, a triangle is simply a rectangle that's been cut in half. And a rectangle's area is length times width. Well, since an area of a triangle is just really cutting in half area of a rectangle, you really end up with 1/2 length times width, or in this case, they call it base times height. So that's the easy way to understand and remember what the area of a triangle is. Another important feature is to understand that when we're talking about B for base and height, base and heights are always going to be perpendicular to one another. Notice that these two form a 90-degree angle. So you can't have this and you can't have some angle going here and saying this is my base because it's on the bottom. Those two lines that you call them base and height need to form a right degree, need to be perpendicular. So that's why you're showing all these different ways you can find the height, whether it's outside the circle, a little bit just move to the left, or right in the middle. Or straight up and down, you don't have to look anymore because it's already 90 degrees. All right, so now we're going to find the area of a rectangle. Area of a rectangle equals 1/2 base times height. We know that the base is 11, so 1/2 times 11, and whose height is 8. All right, they pretty much gave us that one. Well, 1/2 of 8 is 4. 4 times 11 is 44. So this is 44 inches squared. The area of a triangular church window is 90 square meters. The base of the window is 15. What's the height? Now, even though you can't see it or know what it looks like, we can still figure it out because we got two pieces. We can say area equals 1/2 base times height. The area of the triangle, the area is 90. 1/2. The base, they said, was 15, so we're looking for the height. All right, so trying to think of a faster way to do this because 1/2 of 15 is a decimal. Don't want to do that. I think I have an idea. I can put in my calculator is the easiest way, but I'm just trying to think. What can I do? One thing I could do is divide both sides by 15. Or multiply this whole thing by 2 to get rid of this fraction. I think that's what I'll do. I'll get rid of this fraction, multiply this side by 2 and this side by 2. And when I do that, that leaves me with 180 equals 15h. Because this half and this h are going to cancel out. Now we're going to check it after we're finished with this just to make sure that you're feeling good about it. 180 divided by 15. Here we go. 180 divided by 15, and that is 12. All right, so let's kind of double check here. Does this give us the right answer? 90 should equal 1/2 the base, which they said was 15, times the height, which was 12. Does that give us 90? Let's see. 15 times 12 divided by 2, because that's the same thing as 1/2. So yep, we're looking good on that. All right, what about isosceles triangles? Isosceles triangles have the two of the same sides equal out or have all three sides the same. Another thing you need to know about, we'll get there later actually, so I won't get ahead of myself. Find the length of each side. So if it's 80, if this equilateral triangle is 93 inches, what's the length of each side? So the perimeter is 93. Perimeter, that means all around added up is 3. So they're all the exact same. So 93 divided by 3 give me 31. 31 inches. Going to our next problem. Ariana has 156 inches of beading to use as a trim around the scarf. The scarf will be a isosceles triangle with a base of 10. How long can she make the two equal sides? So it's great to draw a picture. She needs 156 around the scarf, so she needs a perimeter of 156. The scarf will be an isosceles triangle with a base of 60. So if this is 60 and she needs 156, what can we do? We can do 156 minus 60, and that'll give us how much she has left. These two sides are equal, so we'll get that answer, 40, 90, 6. So that's how much we have left. Well, I know they're even, so we can divide that answer by 2. So there you go. 16 is what each side would have to be in order to get, no, that's not right. I did this math. What would I stop here for? 16 should be 8. So 20, 48. 48. Yeah. And again, how did I catch myself? Because I looked down and I was asking myself, does that look about right? Does this make sense? Realizing that the perimeter is 156. That's not going to add up to 156, but this should. 48, 48, and 60 should add up nicely. Let me just double check. 48 plus 48 plus 60. So please make sure you go the extra mile if you're working on problems, because that little glance that I do right back at the problem and to check my work as I'm asking us to do down here, these 2 steps, make sure you check your work in your head, see if it's making sense, and make sure you answer the question. That's what those two last checks are all about. So just get in the habit of doing that. All right, last one, I'll do a couple of problems and we'll close it down here, is a trapezoid. So a trapezoid has 4 sides. 2 of the sides are parallel. The other 2 are not parallel. You have this height right here. So that's a trapezoid. Now, one thing that's cool about a trapezoid is you'll notice embedded there's 2 triangles. One base right here and another base here on this red one. So there's 2 actually embedded triangles to help you remember what the formula is. But you normally don't have to remember formulas for area and perimeter because it's given to you. So find the area of a trapezoid whose height is 6 and whose bases are 14. Let's make this 11. That's smaller, and 14. Now, I can't remember what the area is. I just talked about it. I think it's 1/2. Let me go back up and see. 1/2 height, little b plus big B. So 1/2. I forgot that quickly. 1/2 height, yeah. Height, little b plus big B. All right, there we go. I'll try to leave that up there for my sake, if nothing else. All right, so this is a 6, by the way, not a B. So we're just going to plug it in, right? 1/2. I know my height is 14. I didn't really need a parentheses right there. The add up the two bases, 14 and 11, is 25. So there's my problem. So when I work this out, it's going to be 1/2 14 times 25. To keep this simple, I can do 1/2 times 14 is 7, because half 14 is 7. 7 times 25 should be easy. Why? Because 7/4 is easy to count. That's $1.75. But I'm going to work it in the calculator just to be sure. So we're going to work that out. 0.5 times 14 times 25 is 175. Now, did I answer my question? Find the area. Yes, we did. We found the area as 175. Did I answer it completely? Well, let's put in the right units. 175 inches squared, since we're talking about area. And that's, teachers will count off for that little piece there. So please watch this. And tests will test you sometimes on those units. So just watch those. All right, let me erase everything but my original formula, because it looks like I'm going to need that. Vinny has a garden that is shaped like a trapezoid. The trapezoid has a height of 3.4. And the bases are 8.2 and 5.6. How many square yards will be available to plant? So how many square yards? That means how much area. Now I want you to pause this and work this yourself. See if we come up with the same answer. So here's my height is 3.4. And base plus base, 8.2, 5.6, 8, 13. So I'm getting 13.8. So that's 13.8. All I gotta do now is put this in my handy dandy trusty rusty. Well, it's not rusty, but put this in my calculator. So it gets 0.5 times 3.4 times 13.8. And there we are, 6.46. Is that right? Let's see. 618. Let me double check, because I'm doing a math roughly in my head to double check, and I'm not quite sure. So let me 13.8 times 3.4 equals that, times 0.5 equals that. So that looks better. Area equals 23.46, and I want to completely answer by putting the right units, and that's yards. So let me, again, the reason how I'm double checking this is I'm saying what's half of 13, or 14 rather. So half of 14 is 7. So 1/2 times this is about 7. 7 times 3 is about 21. So this answer makes sense. It should be about 21, a little bit more, because we got 3.4, not 3. So that's what I'm doing to check. So make sure, even though I teach this and spend so much time on this, I'm still going to keep checking, because the nature of us is we make a lot of errors in all these steps. So keep that in mind. All right, did we cover everything? Yes. Understand linear, square, and cubics. This is how 3 different measurements. If you just got 1 dimension, linear, 2 dimensions, square, 3 dimensions for a cubic. And we did area and perimeter of rectangles, triangles, and trapezoids. Or actually mostly rectangles and triangles for both, but we did area for trapezoids. Well, guys, thanks for tuning in again. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.